Hi, folks, and welcome back to Physics with Captain Rod. Making this video here to describe relative velocity. Now, really, the term relative velocity is kind of a little bit of a misnomer. It makes it seem like this is something new, and it's really not. All velocities are always measured with respect to some set of coordinates. And, to kind of demonstrate that, we're going to talk about young Timmy here. All right, let's say that Timmy can throw a baseball at 30 miles per hour. So imagine that this truck for a moment is sitting still. So ignore this velocity vector for a minute. Imagine the truck is sitting still, and Timmy can throw a baseball 30 miles per hour. And imagine he throws it forwards, somehow gets it over this truck here, throws it this way. Actually, you know what, don't ask me how, but Timmy's looking through the moonroof. There. And Timmy can throw a ball 30 miles per hour. And that means that, we have this motion detector over here. That means that the velocity that the detector would see that ball coming at, it's the 30 mile per hour. Now, really, that 30 mile per hour is what I would call velocity of the ball with respect to the truck, meaning that the distance from the ball to the truck will be increasing at 30 mile per hour. Now imagine the truck is moving at 60 mile per hour. And Timmy again throws the ball out in front of the truck. Now keep in mind that Timmy can throw that ball 30 miles an hour relative to the truck. Now ask yourself, what speed will the detector see the ball coming at? And most of you probably are going to come to the same conclusion that the ball, as measured by this detector over here, would be moving 90 miles per hour. And that's because of the vector nature of how this stuff works. The velocity of the ball with respect to the detector, or let me say with respect to the ground, is equal to the velocity of the truck plus the velocity of the ball with respect to the truck. The velocity of the ball with respect to the ground is what the detector here is going to measure. All right, now, imagine now Timmy throws the ball straight up in the air. While the truck is moving. So now the velocity of the ball with respect to the truck is still 30 mile per hour up. Well, it's still 30 mile per hour, but now it's up. Now, this equation that I wrote out is a vector equation. So as far as the detector is concerned, the ball is going to be moving 60 mile per hour to the left and 30 mile per hour upward. So what that's going to look like, if I draw this in terms of vectors, we're going to have this 60 mile per hour, and then the 30 mile per hour, and there is the velocity of the ball now with respect to the truck. And we could actually measure this angle using the inverse tangent, and we can find the magnitude of this by the square root of these two things squared. So this is meant to be just kind of an introductory video into the idea of relative velocity. I'll make more that are a bit more detailed. So I hope that this kind of gives you a sense for this. Have a great day.